Okay. So welcome back again. Today we are going to talk about the continuation of the revision of integrals. So here we are, as we saw that in the last lecture, we have many rules here, the first, second, third, and go on. And I think we mentioned all of them here till 22. And maybe there's so many idea we need them, or maybe later we are going to mix, for example, the inverse with the UN or the second one. For example, here, maybe combined with that one, the idea. So how we distinguish them, how we play with them, we will see. So manipulating with them is that playing with them is very important too, because if you have two ideas, we mix it, you should separate them, then you solve them. Before we are going to 8.2, we need to cover all these subjects actually. It's very important. I remember that we stopped here. Where we are? Here, yeah, right? We say how to solve sine square because it's not in the direct one. And I remember I mentioned that if you try to solve any trigonometric functions, first of all, you should think about all these rules that you have. You should compare in your mind. If you have a direct situation, okay, solve it. If you don't have direct, we should change it. So now I'm going to solve that one in chapter 5, which I think just remains example number 5, 7, and 6 to review it. So we have in that example, we have sine square, we see. If we have integral of sine square of x dx, we see that we cannot solve it directly. So we need to change to something from the square to what? To linear. Do you remember that words? We say in the previous one. Okay. So now today, and we have two rules. We say that sine square of x can be changed to what? To 1 minus cosine 2. Do you remember that? And here we have what? Double. Yes, you are right. 2x. So when you say double, means that 2 and anything that we have. So here we are. I am going to change that one to that one, and I see is easy or not. So the integral of here dx will be the integral of here dx. That's why, and I'm going to change like that. Dx minus 1 over 2 cosine of 2x. And you know, the number is what? Is simply, it's the first rule. Can we bring it out? You can do it. So factor 1 over 2 and you will get x from the first integral. Do you have any question about the first part? Easy, right? Like the first rule here. Look, if you have a k bring it out and you get 1 x. So now here instead of k, I have 1 over 2. Minus 1 over 2 also come out. It remains cosine of 2x dx. Just I bring it out 1 over 2. Is equal, okay or not? Factor, bring it to out. So again, we have what? We have 1 over 2x minus 1 over 2. So the result of that one will be what? Yeah, we say alpha. Do you remember alpha? Which is equal to cosine will be changed to sine 2x over 2 and all of them plus c. So later you will get 1 over 2 x minus 1 over 4 sine 2x plus c. That will be your answer. So the same thing is true for what? The same thing is true for cosine square. Look at here. The same thing is true. If I have 1 over 2, I'm going to change cosine square to that rule because we have that one, double angle or half angle. Then that one will be 2x. Then again, 1 over 2 will be 1 over 2x, and that one will be 2 over 4. Do you have any question about that example? Dears, do you have anything? No. Now we have another thing here. You can see another example. I'm going to leave that one for you. Just look at it, and it's easy. You multiply that one first. No. You can do anything else. No. So why we change to that one? So kindly check everything is clear here. Kindly check that one how to solve it. You should use that rule, that property, or identity, anything that you like to call it. So we change that one to that one, and you'll get this result. Let me that one homework for you. Just think about it. Understood? And if you don't understand, bring it back to me. It's okay. Understood? Good. Now in chapter 8.1, we mentioned that example how to solve, right? Also, you can think about that one. Let me solve that one for you. So the important things in that sine and cosine is what it depends on the properties that we have. When I say properties, I mean that one, how to multiply them, how to find the situation. Before, especially when you have multiplication and addition or subtraction with another multiplication between sine and cosine, we have two famous rules. Do you remember that? So let me write down for you, and you know what I mean. We have two famous rules from multiplication or addition between m1, m2, let's do that one, addition or multiplication m1 and m2. Especially for sine cosine. You know, if I have sine of alpha plus beta, x plus y, 2 plus x, anything. So it's equal to what? You heard about that one before in high school. Sine alpha, let be xy. Maybe you are familiar with the xy. Let be that. So xy. So you say sine of x, cosine of y, right? Plus a cosine of x, sine of y. Am I right? So how about sine of x minus y? The same, right? Anything changed? No, nothing changed. The same, just we have addition and subtraction. That's all that we have. So how about cosine? Hello? Yeah, cosine of a, right? Cosine of y, okay. Plus, we change that one. Look, we have addition here. We change to the minus. So sine of x, sine of y. Thank you. So in case I have a subtraction here, that one will change to what? To addition, the same one. So we are going to use all these rules together. What do you mean by that? For example, let me write also the first, second, third, also fourth for you. Let me play with them, add between them, add these two together. Now, for example, if I am going to add equation number one, the first one plus the second one, I'll get what? If I go to add these together, so I'll get what? Yalla, add the first and the second. Yes. Yes? No. No. 2 sine x cosine. Yes, you are right. So for example, if you add these together, that one will cancel that part, right? That one cancel that part. Am I right? So that one plus that one, they are the same. So I will get what? 2 sine of x cosine of y. Understood? How about that one? That part? That part, nothing changed. So I will get sine x plus y plus sine x minus y. Can you imagine that one? Easy or not? So we are going from these four together. Later, we are going to get many rules together. For example, if I am going to add a third with the fourth, yalla, add a third and fourth. Now we cancel that part. Am I right? So 2 from the right side, I'll get 2 cosine x cosine y. From the other side, left side, I'll get cosine x plus y plus cosine x minus y. Am I right? Understood how to get many rules from 2 rules. When I say 2 rules or 4 rules, because they are the same. So we can play with them. We can get something else. How about if I have, for example, sine 2x plus 1x. I'll get what? Instead of xy, change it to 2x plus 1. I'll get what? Hello? In the previous one, we have what? If I have, yeah, if we have 2x plus 1x, I'll get what? We see, forget about what we have, x or y. We say is equal to sine of the first, cosine of the second, am I right? Plus cosine of the first, sine of the second, am I right? Understood? So why we mention that one? Why we play with that one? Because when I have such rule like that, I remember there's something belong to x. Understood? That one, because we have m1, m2 plus m1, m2, and they are cosine and sine. So I'm going to check out where's x, where's y, the big one, okay, in the rule. Which one is x? Which one is y? Which one is alpha? Which is beta? Which is 1, 2? So that's why here, when I have such example like that, our mind will be on that rule, So tell me, which one is x, which one is y? I can see that one, right? X and y. So I have x and y. Sorry. X and y. Now I'm going to change to x plus 2x. Understood what did I do? So instead of these rule together, which I cannot solve by any method, I'm going to summarize it to make one part. So that's why I can see that one is equal to that one, and I know 1 plus 2 is equal to 3. And I know how to solve that one. Understood? The next step. So here, instead of all these, integral all of these together, I can say integral of here. And that's why I can say integral of 3x. And I know that one is equal to what? Minus cosine 3x over 3 plus c. Easy. You got the idea? So maybe at the beginning, that one is not easy for you. Because you say, oh, I have that one. And maybe you didn't think about how to bring these ideas. But now you know, if I have multiplication between sine, cosine, cosine, sine, and there's addition or subtraction between them. So there's 2 or 4 main rules that we are going to play with. Understood, dears? Good. So that's about example number 3. Now I'm going to example number 4 in 8.1. So how we solve that one? 1 from 0 to pi over 4, 1 minus sine. Okay. From 0 to pi over 4, 1 plus or minus, I don't forget, 1 minus sine. Any idea? This is direct? No. Can we use ln? Yeah, derivative of denominator is equal to what? Yeah. If I use ln, derivative of it is equal to what? Minus cosine of x. Is that exists in here? So ln cannot be used, right? We cancel that idea. So can I bring that one to up and use u du? Can I bring one minus sign to up to numerator? No, because why? Say something. Why we cannot bring it to up? Because by conjugate. Yeah, we are right. Okay, so there is no idea to solve. We stacked. We cannot do anything. So I'm going to multiply this part by what? By conjugate. So what's a conjugate? Yeah, exactly. So I say 1 plus sine of x, 1 plus sine of x dx. Yes. Which minus? Yes, conjugate, it should be the same with a different sign. Conjugate بكلي أول period. No, for now, no. There's no derivative. Forget about that one. There is no derivative of here. Derivative of here should be minus cosine of x, but we don't have. So we cannot bring it to here. Understood? So if you think we multiply here, for example, if your idea is like that, you think is if I put multiply minus cosine of x over minus cosine of x, you think like that? Bochi minus cosine naheni. Ah, yes, because here you have minus. I have what? Let that denominator be u. U is 1 minus sine of x, right? So derivative of here is equal, that's I have that minus, that's why. Okay. Any other question? I thought what you say why we don't multiply by that one. Okay. Do you have any question, dears? Okay, so next step will be what? Yalla. We should finish our multiplication, right? So I'll get what? Over what? Yes. So I'll get from 0 to pi over 4. I'll get 1 minus sine square of x. Okay. 1 plus sine of x dx. Okay. What else? Actually, it has many ideas, not simple example. If you don't know, it's okay, don't hesitate. Later, you will deal with it. Yeah, next step, we change that on 2 square. So what's the purpose of that step? Okay, exactly. So we have cosine square plus sine square is equal to 1, right? So I'm going to use that one because I say 1 minus sine square of x will be what? Will be cosine square of x. You are right, 100%. So I'm going to change that one to what? To cosine square of x, 1 plus sine of x dx. As I told you, like a chess, you should think about it. Put your mobile away. Then next step. Next step. Thank you. Hey. Hello. No, first we should solve the example, then the boundaries later. In your lecture notes, yes, wait, derivative of here. Oh no, we cannot do it. What else? Hey, do something. You start. Don't leave it. Do something. At least try, even if it's not correct. Yalla. Thank you. We separate them. So I have what? I have 1 over cosine of x okay. Hey, do something. Now 1 over cosine squared is equal to what? 1 over cosine is equal to what? 1 over cosine is equal to what? Second. So we have a second. Am I right? Do you know? 1 over cosine is equal to second of x. So how about square? I'll get a square. Okay. What else? Sine of x, cosine of x. Let me write down like that. It's better. Understood? I have cosine square. Make it cosine, cosine. 1 of cosine, sine of cosine. Why? Because later I'll get what? Do you have any question? Can you solve that one? That's why you say maths is hard, because you didn't review anything. I can see. So the first integral is equal to what? Yeah? The integral of the second square is equal to what? Tan? Tan or tan square? Tan, okay. So that one is equal to tan of x. Thank you. Thank you. How about second tan is equal to what? Again, many thanks. Second of x. You need to review, I told you. So we have what? We have from 0 to pi over 4, 0 to pi over 4, and you'll get numbers. You know, is equal to what? Is equal to what? Tan, yes. Tan of first minus tan of second plus second of first minus second of the second. Pi over 4, 0. Pi over 4, 0. Tan of pi over 4, tan of 0, 0. Second of pi over 4. Second of 0. Cosine of 0. 1. So 1 over 1, 1. And that's what we have. Is equal to 3 square root over 2 minus 1, something like that. Okay. Yes, I am right. There's something wrong. Here is equal to 1. So let me fix that one. So I'll get what? Understood? Of course not. Right? You don't understand. So where's the difficult part? Tell me. Which one you don't get the idea? Which one is the point that you stuck here? Yalla di. Which one? Maybe at the beginning, you don't know why we multiplied here. I told you because we stacked. We cannot solve that integral by any methods. We cannot solve that example by any method. We cannot use len. We cannot bring that one to up because we have -1. So the second idea also canceled. So there is no way to solve. It's 1 minus sign is not equal to anything. But I remember 1 minus sign squared is equal to something else. That's why we multiplied by the conjugate. And here we are. We multiply by conjugate. After that one, you know, I will get the first square minus the second square. So we get first square minus second square. And I know that one will be cosine. Then, as he said, we separate them. Why? Because still I cannot solve that one. Still I cannot solve that one. In each step, I'm thinking about it. We cannot solve that one by any methods. We cannot say by len, we cannot bring it to up. That's why I'm going to separate them. When you separate them, I will get that one and that one. And I know 1 over cosine square of first second and second square is direct. So I can solve. And I don't know how to solve that one again. Can you solve that one by another method? Hello? Can you solve that one by another method? Without that, can you solve by another method? Use another idea? Huh? So, you are right. So, I mean, so let me see. Shall we solve that one? I told you it's like a chess. You cannot solve by one method. So if I have something like that, sine of x, cosine square of x, dx. So let me bring it to up. I say cosine square of x by minus, right? Sine of x dx. So I make that one as a box, d box. Understood or not? Derivative of here is equal to what? No, minus. So I need minus. Now box d box u du. Now we say is equal to what? We have that minus. We say we are going to. This is not inverse actually. This is power. It'll be like that. Then minus by minus, it will be what? Plus. So, and that one will be 1 over cosine of x. And it's equal to what? 1 over cosine second. Can you imagine? By the second method, you get the same. Yes. Another method. رقيق كتير بو. هوش رقيق كتير. هل شيء كشته. من وين بباش الزانم؟ زو أمام دسكة. 1 over شيء ما نهبو. Sin x cosine دوجا x 1 أبو. بقول رجيا حالم كرد ايش ما ايرا وانا بو يسبور رجي بيشو حالي كمان من والله ما جياكم اما دو جا يقدا انا بو ايرا يقدا نجبو ايرا اما كاتتان او جاكات السكن انتجرال السكن تانا كات السكن you got it كاك جان or not اه بس زعما بس ام بلس يا اوان يا اخوي بلس اللي بيني انا اتواني اتش شلون داينه اتواني بنوعك تيجي ام باوندري انا داني اوكي I got your question اتواني باوندري انا جورج دانري look at here we can substitute the boundaries like that look we got tan of x plus secant of x okay you can bring it substitute separately or together the same so I can say is equal to tan of first plus secant of the first minus tan of secant of the second, and you'll get the same. That one will be 1 minus 1, that one will be 0, that one will be as tan of 0, 0, and secant of 0 is equal to, sorry, I did a mistake, wait, I did a mistake. Tan of pi over 4, 1, secant of pi over 4, square root of 2, tan of minus, tan of 0, 0, secant of 0 is equal to 1. Then later I'll get 1 plus square root of 2 minus 1, and I'll get square root. Understood? So you can solve by 2 methods, 3 methods, I don't know. It depends on your idea and your background. So you saw that in that part, that small part here, we separate, that's why I say write your steps. We separate the integral and we change to that one, or you can solve by another method. The first is equal to secant squared, the second is equal to that we did before. Do you have any question before we solve the example number 5? It's easy, very easy actually. And take care about that one. In 8.5, we are good. You have in your homework, you have something like that. 8.5. That one is simple. There we have something you should do like that. Then we have something else, another techniques. Be careful. The same idea will repeat. You need in the integral, you need to collect the ideas. Then you mix together. Otherwise, you cannot. That's why I say every time the table should be in your mind. When you have a secant square, you shouldn't hesitate and look at me. Directly, you should see equal to 10. Otherwise, means that you are still before Cal 1. You need pre-calculus. So kindly repeat it or review it. We have what? We have polynomial over another polynomial. What do you mean by polynomial? What's a polynomial? Hello? What's a polynomial? Define it or tell me, huh? Anything. Thank you. What's a zorada? In mathematics? Xi zor. Okay, you are right. Xi zor. So what's the shape? What's the formula? Yes, we see P of x, for example, or f of x is equal to, for example, 2x to power 3 plus 5x to power 2, right? Like x is zor, as she said. We have many things. So if I have polynomial P of, we say nx over P of mx. What do you mean by Pnx, Pmx? Means that I have two polynomials. One of them has a power, the other has another power. We have three cases. Okay, I'm not going to repeat that information in 8.1. So kindly, carefully listen to me. We have three cases. N greater than m, n equal to m, and less than m. What do you mean? For example, I have x to power 3 plus 5, x to power 2 plus 1 over x to power 2 plus 5. So n numerator is exponent greater than denominator's exponent. Now you understand what I say, right? How about the second case? We have, for example, equal, thank you, 5x plus 1, x minus x squared plus 2, right? So you can see n and m equal. How about the third one? Denominator is greater. Right? Denominator, x to power 4, is greater than x to power 3. We have these three cases. In two cases, couple of cases, look at here. If numerator greater or they are equal, it's better to use long division. These two cases need long division. It's better to use long division. So in 8.5, we are going to, especially in the exercise, we have exponents or the degree, let you say degree of the polynomials are equal or greater. So in that case, we are going to use, what do you say, long division, then we are using something else. How about if the small in 8.5, we are going to fix in 8.5 that one, not now. So for now, I have such example like that. Look at here, which case that I have? Numerator and denominator greater or less? Numerator is greater, right? So I'm going to use what? Long division. So how's going on? How we solve that one? Long division is like that, understood, right? Which we have 3x squared minus 7x, 3x squared minus 7x over, right? Let me check, 3x plus 2, thank you, are right. And so now it's time to use long division. How? Learn how to use. So I have division, so I say I have that one. So here to here, x to x squared. So I need what? Just one x, right? X multiply here, it will be 3x squared. Understood, dear? Now we say by subtraction. So I'll get what? Or you can say plus and minus. So I'll get what? Minus 7x. Understood? So I'm going to ask you again, do we have another round or not? Sorry. Something left. So x multiply 3x, x multiply 2. So I'm going to use that one and multiply that one. So I'll get here. Now we change the sign. We say we change that sign and we add them. So I will get that one is equal to 9x. Understood? Do you have any question? Dear students, kindly ask if you don't understand. Each step, single step, just tell me, please. So now we have a long division. We did, and you saw that one before, I think, in secondary school. Now, that one remains. Still, we have another round of division or not, and why? That one left. So still we have another division. Yes? Why? Yeah, a little bit. No, the reason is no. You are right, X, but why X? Why you say just X again? For example, if I have, yes.
Can write 3.
No, my question is what? Can we divide another round or not? Yes? She said yes, she's right. But tell me why, the reason a little bit. Not like that. A little bit, but يكتس. Yes, the same, but as I say, listen, because the degree, and generally speaking, all of you is right. Because the degree of here equal the degree of here, and we say that if the degree is equal, with the division. Understood? 20 خواري degree is equal the degree of here. وقوا جاري كتير 9x مهبة divided 3x plus 2 كم. So I'm asking the degree of here not equal to here. So I told you the degree is equal, we should do what? Long division. So that's why I have another round. Okay, you say you are right, you have x, you are right, you have say something, okay. But because the degree of here is equal. How about if? How about if, for example, we have that one and here is 2. Can we do another one? No, because degree of here is less than of here. Now you get the idea, right? That's why. So we have another, again, we should divide. So tell me about which number we should put it here? Minus 3. You are right, thank you. So minus 3, multiply 3, nothing, and I'll get x, right? So again, we change that one, and I'll get 0. So that one is called, yes. Again, the same mistake. I am very busy today, I don't know. And minus 3, sorry, minus 3 multiply here, I'll get minus 9. Minus 3 multiply here, I'll get what? Minus 6. So I'm going to change the sign. We are going to change the sign. That one will be positive, that one will be positive. So that one with that one will cancel each other, and I'll get 6. It's called remainder, right? So now if I have that long division, look at here, dears. I know you are a little bit tired, but actually all this in high school. Actually, go check grade 10. Just go check, or 9 or 10. Go, you find all these subjects. And because you have a gap, that's why I try to fill every single steps for you. So kindly do not be tired. Okay, that's why. Okay, now in that case, if I have that division, I see is equal to what? I see is equal to now you understand. And so that one will be the dividers, that one will be R. If I have nothing, I will not write anything here. Did you understand what did I do? So the integral of 3x plus 2, 3x squared minus 7x will be dx, will be changed to the integral of x minus 3 plus 6 3x minus plus 2 dx. And you know how to solve that one. Yalla, give me the first one. The first integral equal to what? Equal to x dx minus 3 dx plus 6 3x plus 2 dx. Yalla, tell me, is equal to what? If you don't know how to solve that one, it means that you didn't study anything. Because all of them in the table number 1. So let me check you. Yalla. Thank you. The first will be, okay, minus the second, 3x. Thank you. The third part, wait. Math is not hard. You are not time. You don't have a time. Yalla. That one. They. Okay. You.
So the degree of the increase is bigger than, lower than the
Mm-hmm.
So what we're going to do, I'm not sure, but we will use limit, so this fraction, and we change these long.
Yeah. So briefly, we have a fraction. Derivative of denominator is equal to what? 3, right? I have what? 6. You can divide or separate them, right? I'm going to write that one by 2 by 3. Am I right? 6 is equal to 2 by 3. So I'll get 2, 3, 3x plus 1 dx. Now I have a fraction. The first idea, I say what? Think about ln. Do you have a derivative in numerator? Yes. So direct IC is equal to 2 ln 3x plus 1 plus c. And you know. Everything we talk about or you thought about, we need them. And later in 8.2, it will be more. In 8.3, it will be more. So please do not study. That'd be, yeah, like a bunch of work you left. So okay. Okay. I think it's time to give you some rest.